Okay, very well. I thought of doing a video where I was going to show you every single piece and how it goes into the airplane, but I decided against that, and instead I'm going to give you an overview. So what we have here is the Anaconda. I'm going to go, I guess, front to back. And what we have here is the steering servo, and that just comes out to this servo connector here. I also installed another sensor. I installed an airspeed sensor. What it is just a pitot tube that I 3D printed apart that basically just sticks into the foam, comes out this way, and it's hot glued in there. And the two lines come out of the sensor, or out of the tube, and go into the actual sensor back here. And this sensor just has a connection to the I2C connector on the flight controller. So that's that one. We have the GPS unit, which the base is hot glued onto the foam airframe. And then I have some screws to install the part that actually carries the GPS. And then it comes through here. There's the GPS cable, this black one. And then it goes into that CAN bus and comes here. So this is going to install, I use the same cable as the I2C, I think that's okay. It has 4 wires, and I'm going to use it to connect it to the CAN 2 on the flight controller. The other thing that I have here is, that's the location where my power distribution board and my telemetry radio are going to install. And that's the base with the soft mount where the flight controller is going to be installed. So that's already attached to the bottom of the plane. On the back there, it's hard to see, you can kind of see it from this angle. Back there is my ESC. And so the ESC wires come out here. We have a programming wire that I'm not going to use anymore. We have a power cable for the ESC and the throttle cable for the ESC. And I believe this is a reversing signal wire that I'm also not going to use. I'm just going to use it normal. Okay, so those are the pieces that are installed onto the airplane. Now these are my little antennas that are going to be for my telemetry radio. And these are just antenna extensions that I 3D printed a little flat piece that I then use the zip tie. And the antenna is actually mounted onto that and screwed in. So it gives me a very firm connection and it doesn't turn. And then it's just a normal pigtail extension that's going to go into my telemetry radio. Okay, so let me show you what that looks like. I have the electronics here on the table. And of course, key pieces of this are going to be my power distribution board, which is a little hard to see there, but it's a Maytech PDB hub, I believe, for 6S. And that's receiving 6S voltage from the battery. So there's my battery. Here's my Cube Orange power module, which can take the 6S. I have it split here. This is an adapter that I made where the power comes, is going to continue onto the ESC, and it splits up into this PDB. Now, this is going to be my first power source for the Cube Orange, and then this is going to be a secondary. This secondary comes from this Mach VEC, can take 2 to 6S, and it's going to output the 5 volts that the flight controller needs. So even though I'm going to have only a single battery connection, and I'm using this to supply power for both, they are redundant in the case that if any one of these VECs fails, the other one will continue to provide power to my cube. Now, this power hub is also providing power for my telemetry radio. This is very important because this telemetry radio requires way more power than you could get from just this connection. So actually, this power connection overrides the power that normally would come from the cube. This is going to go to the telemetry connection. But the power for the actual radio transmission is coming from this connector and from the PDB, or actually from the power hub down there. Okay, so that's very important because this telemetry radio will use a good bit of power. Now I just have it temporarily with the antennas because I don't want to, by mistake, power it on and not have the antennas on. That could fry the radio, so that's there. Now the other thing that I'm pulling power from here, there's a 10-volt power output on that power hub, and that one is going to supply power for my digital video system. So I'm going to use a DJI system. This is the plug for the DJI. So it's ready to go. So that's going to be my HD video. And it's going to come and connect into the telemetry 2 port on the Pixhawk, because I am going to be displaying OSD information on that. I'm going to be using the hack for DJI, so I can use the WOSD and display OSD information on that. I'm also going to be using a LiDAR. This LiDAR is going to connect into what would normally be the GPS port, but really these are just serial ports. So as long as you have a power ground TX and RX, which I do, I'm going to use this LiDAR for eventually doing autonomous landings and takeoffs. Okay, and these are just stand-ins for my airspeed sensor, which is going to come and connect into the I2C input in the flight controller. And this is a stand-in for my GPS, which is going to come in and connect into the CAN bus. So let me go ahead and plug everything in. I'll show you how it all then kind of goes together. Okay, so I plugged everything in. Here's the flight controller. I'm turning it around so you can see where everything is connected. It's a little hard to read, but this one says CAN 2. And CAN 2 is the CAN bus where I'm going to plug in my GPS unit. Now over here I have I2C, so again that's going to be my airspeed sensor. This is the GPS 2 port labeled on the flight controller, but again it's just a serial connection, so that's where the LiDAR goes. Over here I have telemetry 1, which is where the telemetry radio is connected to, and here I have telemetry 2, which is where the DJI air unit is going to be connected to. Okay, and I have my 2 power connections, and so this is the way that it's going to be installed in the airframe. This is going to be way harder to see what's installed on the airframe, but that's basically the way that it's going to go. And over here what I did is I made this connector so I could easily connect and disconnect the wings. All I have here are 2 ground and 2 power for redundancy. I have 1 normal servo wire that provides 1 signal, 1 ground, 1 power. And here just an extra ground and power cables. And so basically I have 3 signals. And these are going to be for the flaps, for the ailerons, and for the elevators. And one's going to connect to the left side of the airplane and another one to the right side of the airplane. So these 2 are about identical. And they connect into my RC outputs 1 through 6. I have 2 more. One is going to be for the throttle. The other one is going to be for the nose gear, for steering the nose gear. And then finally this is going to be my RC in. I'm thinking and debating whether I'm going to need another RC out, but we'll see about that. That would be nice because I wanted to control some lights. Maybe I'll just put lights always on. So I have an RC switch, but I'm out of RC outputs and I don't want to mix them. I want to have everything independent. So I'll keep everything like this for now. Okay. Anyway, so that's the wiring harness. This is going to go into the vehicle. Everything has been measured already. This is long enough to reach all the way to the nose. This is long enough so that my batteries will plug in here. This is going to sit right at the place where I have my little pigtail extensions for the antenna. And these are going to be right where I can access them from the wings. One of these is going to go to the GPS. The other one is going to go to the airspeed sensor. So yeah, that should do it. Telemetry radio, LiDAR, airspeed sensor, GPS. Those are the main sensors that I'm going to have on my Anaconda. All right, hopefully this is useful. Let me know if you have questions. Keep them up in the air and don't forget to subscribe and like this video. Bye-bye.